Okay, in this section, we are going to be looking at what I like to call a power to a power. So looking at example 1, we're going to break it down into what it actually means. But if you notice, you have an exponent raised to another exponent. So I will refer to this as a power raised to a power, which is different than what we did yesterday. Now, if we break it down like we did yesterday and say, okay, what does this mean? I'm going to take that off for a second. So that whole parentheses, m to the third, that monomial, is being raised to the fourth power. So what that actually means is m to the third times m to the third times m to the third times m to the third, if you were to actually write out what it means. And then you could go one step further, which we won't do every time, but m to the third, remember, is m times m times m. And so you would keep doing that. And we would be left with how many m's? You can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have our final answer is m to the 12th. So if we were in class, we would go through a lot of these so that hopefully you can see the pattern. But when you have a power raised to a power, notice we kept the base and multiply the exponents, because if we want to end up with 12, 3 times 4 is 12. So when you have a power raised to a power, you keep the base and multiply the exponents. Now keep in mind, if you did not know this rule, we did this problem without the rule. So if you go back to what does it mean, you don't have to memorize the rule necessarily, but it will just help you in the long run. So keep in mind, when you have a power raised to a power, keep the base and multiply the exponents. So if we were to apply that, let's look at example 2. We have a power raised to a power, and so if we were to write out what this means, it's going to be x to the second times x to the second times x to the second 5 times. And what we're going to end up with is x to the 10th power. So if you need to write it out, write it out. But if you recognize that it's a power raised to a power, you can use your exponent rule. Now in example 3, at least when I'm first doing this, I am going to write out what this means, because now I have a coefficient. And some students struggle when there's a coefficient like 2. So what this is saying is 2y times 2y times 2y times 2y. Now remember, all these y's are really y to the first power. And I can also multiply in any order. So if I wanted to rewrite this, put all my 2's together, all my y's together, I can. So 2 to the 4th power is going to be 16, and then y to the 4th power is y to the 4th. Now that will simplify if I keep going to 16y to the 4th. So when you have a coefficient, you have to remember 2 is going to the 4th power and y is going to the 4th power. It's all one time, because you're taking the whole monomial to the 4th power. But just remember, it's that whole monomial going to the 4th power. So, for example 4, if you want to write it this way, you could. -4 is going to the 3rd power. The m is going to the 3rd power. And the n is going to the 3rd power. So either write out what it means, or you could do it this approach. So this is going to give you negative 64 m to the third n to the third. Okay, let's look at example 5. And I'm going to show you some students, they actually like to write it out. So honestly, whatever is your preference and however it makes sense for you, that's the approach I would use. So if you're a student who likes to write it out, this is what it means. So when you have 4 times 4 times 4 times 4, you're going to get 256, because that's 4 to that 4th power. And then a to the third raised to the 4th power is going to be a to the 12th, because 3 times 4 is 12, but you can see if you write it out, you're going to get 12 a's. And then b to the 2nd raised to the 4th is going to be b to the 8th. So that's your final answer, 256, a to the 12th, b to the 8th. Okay, let's look at this last problem. Really is just to show you the differences. So notice 3x to the third, only the x is going to the 3rd power. So when you're evaluating, I always prefer you to put parentheses before you plug in whatever you're plugging in. So in this case, this is really 3 times 2 to the 3rd power. So if I'm following my order, I need to do my exponents before I do my multiplication. So 2 to the 3rd is going to be 8. So I have 3 times 8, which is 24. And then the second is the quantity of 3x. So all of 3x is being cubed. And so if I were to write my steps here, you could even still have a parentheses within a parentheses. And we are plugging in 2. So I would do my parentheses first, which would give me 6. And then 6 raised to the 3rd power is just 6 times 6 times 6, which would give you 216. You can also check these on your calculator if you will use your stow function and do 2, stow it as x, and then enter your original problem. You'll see that that checks out. Okay.